Good afternoon, everyone, and welcome to another edition of the M Word. My name's Robin. I'm the technical director here at Man and Machine in the UK. And as ever, it's a pleasure to have you with me this afternoon. For those of you that are new to these sessions, we run them as often as we can. Please give us a like, give us a subscribe, drop us a comment, and let us know what content that you want to see. What's going to help you out? What's going to save you some time? What are you struggling with? Is there something in your workflow inside of AutoCAD, LT, Revit, Inventor, whatever it might be? Let us know what you want to see, and we will share tips, tricks, and share our knowledge with you to try and boost your productivity and make your day-to-day lives easier. Slightly different session today, in that I'm joined by my colleague and good friend Chris England, who's going to talk to you about Moldflow. Moldflow, if you're doing anything with injection molding and plastic parts, is a crucial tool that allows you to analyze early and investigate different methods and different ways of working early on in the design stage to spot issues before they arise in the factory or on the shop floor, to make sure that your molds are going to fill the way that you expect them to make sure you're not going to get any warpage. All these kind of things that ordinarily we have to wait until we run something on the machines to figure out if we're going to get a failure. We really want to try and reduce our wastage and reduce scrap. So the earlier on we can bring those processes into our designs, the better likelihood we have of getting nice, smooth adoption and a good filling process on the shop floor. So without any further ado, I will hand over to Chris for the next sort of 20 minutes or so. He's going to talk a little bit about the process, and he's going to demonstrate Moldflow Advisor and really show you how, if you're using something like Inventor and you've got a 3D model, we can leverage that to really get the most out of what that product will turn out to be and our process end to end. So from me, that's it. Enjoy the session. Chris, do you want to come and plug in and get yourself started?
Thanks, Robin. And as Rob has alluded to, I will be discussing enhancing efficiency with Moldflow, benefits of using plastic injection molding simulation. A little bit more about myself. I'm Chris England. I am the MFG Technical Development Manager here at Man and Machine. I am a certified Autodesk trainer and an MFG application specialist, and I've been with Man and Machine over 6 years stage, and I've been using Autodesk solutions for more than 15 years. And I'll just say it because it's there. If I had a quote, it would be do it once or automate it. So jumping right into it, this stage, from a Moldflow point of view, we have two sort of main packages that we have on offer, it being Advisor and Insight. So those are the two main branches that we have within Moldflow. And then if we start to break down into each, or what comes with each version, or what options we have with each version, with Advisor, we have a premium option and an ultimate option. Whereas with Insight, we have the standard, premium, and ultimate versions. Now, my very brief and simplified comparison that I have up on screen here is just between the ultimate version of Advisor, Advisor this side, and Insight this side. And they're both the ultimate versions. And if you're wanting to do a comparison, you can find the ability to do a comparison on Autodesk website at www.autodesk.com/compare-features/Moldflow. We will put a link in the bio as well if you missed that. But in layman's terms, what we're actually looking at here is, I guess, Advisor being a bit more simplified and a bit more, I guess, a few more tools to make things smoother and easier for industry leaders or industry people like designers and people, I suppose, that aren't as high up on the engineering or in the specialist field of mold design, as it is quite a niche sort of market. And I guess Insight with those advanced tools that allow us to sort of get into the nitty-gritties of mold design. So within the, like I say, my simplified comparison here is just looking at the two ultimate versions and some of the, I suppose, unique factors rather than looking at the full list. If you want that exhaustive list, go and have a look on the website on the comparison. But just on a top level, with Moldflow Advisor Ultimate, we have unlimited local solving. We have some simulation advisors as well as like wizards and stuff to help us along. DXF creation ability, as well as ability to do Moldflow design and actually a Moldflow design environment included, which I'll be showing a bit of shortly. On the Insight side, we have some cloud solving options start to become available. We have the ability to import assemblies. We have API access, which is always handy on the automation side of things. Tool and flow analysis, software interoperability, and things, or the availability of Helios PFA. If you haven't heard of it, Helios PFA is a software tool from Autodesk that performs progressive failure analysis on composite materials using an FEA approach. So quite a handy set of tools, but very advanced and very high level. And to be clear, today we'll be focusing on Moldflow Advisor as it. I will be showing, I suppose, how we can start to unlock efficiency by doing our analysis at a very early stage and at the design stage. So when it comes to unlocking efficiency, we're going to aim to improve quality. Of course, with any product manufacturer, this is always going to be the goal. And the other side of it being we want to save time and money. Now, a lot of you will be familiar with the old triangle where, we put a focus on one of these or two of these sort of factors. The third is normally the sacrificial lamb, as it were. So it gets sacrificed. So, i.e., if we wanted a product in a short period of time and very cheap, obviously the quality is going to need to be sacrificed, and vice versa. If we wanted it really quickly but of high quality, we're going to have to pay a lot. And I guess what I'm hoping to show or add in here is the ability to explore more options. So I guess with these three sort of topics on a highlight, we might want to look at that triangle with a little bit more complexity and start to have the added scope in there, which goes into the triangle and all adding up to quality. And to be clear, I do see time and money being a very similar field. I know they're not the same thing, but often enough they contribute to the same sort of place. People's time costs money at the end of the day. So yeah, we're going to try and use Moldflow, or at least realize a few tools within Moldflow that can hopefully help us save time, improve quality, and explore more iterations early. So to break that down, on the improved quality side and how we might go about that is being able to do more testing before manufacturing. This means that with Moldflow simulation tools, we can optimize our material usage, and that allows us to, I suppose, look into various material specs and test various materials at an early stage, identifying the best for our particular product. We can achieve lighter parts without compromising quality, and of course that may be a goal. It might be just keeping the strength up of a particular product, or whatever our goals are, we can achieve them and test for those variations. And then lastly, what we're going to aim to do is improve quality, or improving quality does start at the design phase, and so should your use of Moldflow. I feel that a lot of people, or a lot of businesses rather, tend to look at Moldflow as an expert product. And yes, of course it is. As we discussed, Insight is a very comprehensive simulation tool, but things like an Advisor have a nice entry for designers, and we can be doing some sort of lower end simulations or preliminary simulations at an early stage, and I believe that's where Advisor should be sitting in the market. So saving time and saving money, less design iterations in general. Now, of course, I'm proposing that in the design phase we are going to do more iterations and test more, but the result of that being fewer physical prototypes, right? Digital prototyping saves us physical prototyping at the end of the day. And due to less physical prototypes, we of course will save scrap and rework. So mold design is very expensive, and of course to create a mold is always a very costly exercise, so we wouldn't want to be getting it wrong. Thus, the more testing we can do early, the better it is. And of course, if you are outsourcing your engineering or your mold design from some sort of mold experts or molding engineer firms, at least we can be sending, especially if our designers are doing some sort of simulation, we can be sending better quality models to start with, knowing that we might rule out some of the potential fail criteria that we might hit at that early stage, and thus saving on outsourcing costs. So what are we talking about when we say explore more? Explore more options early, right? Of course, we have tools like Inventor, and obviously there are other CAD modeling tools out there that can be used, but Inventor being our Autodesk flagship for myself, or perhaps Fusion, but both of them being parametric tools. And that's what I'm getting at, is that from a design phase, it's not hard for us to adjust models and do various little tweaks to our models within the parametric CAD environment to allow us to explore more options at an early stage. So digital prototyping, of course, isn't free. We're paying for someone's time to run these simulations. And of course, if we need to upskill them and all the rest, it's not free. It's not fool ourselves here, but of course it's a lot cheaper than physical prototyping at the end of the day, and that's what we're getting at here, is that we can run multiple tests to reduce the cost of physical prototyping. It's not that it will never be required, but just that we can save. And we can explore design traits, not just molding techniques, right? And that's what I'm going to be showing off a little bit of today, is that, from a designer's point of view, there are things within the molding industries that, well, it's probably common knowledge, and my example today will probably be a very simplified version. But of course, there are things within the design phase that can affect the overall mold results later on. And as your designers can then, or if your designers are then handing over a better quality design, we can save on our expert engineers' time, or those fees if it's outsourcing, and thus getting a better product quicker. So with our goals in mind of improving quality, saving time, and exploring more options, I'm going to jump into Moldflow Advisor now, and let's have a look at the actual product. So I'm going to start off by showing you my model, and as you saw in some of the images, I'm going to be using this half a drone body as my example, the top cover of my drone body. And yes, it's a made-up drone. It's a man and machine design, so not a real design at this stage. But I'm just going to use a simple example as a comparison. So I have at a starting point this version 3 of my top cover, and here we have a baseline design. The parametrics haven't changed in terms of the length of my actual wings or any of the body shape, or any of that hasn't changed. We've got ribs at the bottom on the internal. And on my version 5, all I've gone and done is added in some extra fillets. So I've added some fillets on the top, and I've not even filleted every edge. I've just added in a few sort of key areas. So I've done on the underside and on the top side a few extra fillets. So a simple design tweak. It's not a big change, and it's nothing. It's not going to change the world at this stage, but we can see how it may affect my mold design. So if I jump over to Moldflow Advisor, what I'll do firstly is I'll just show you some of the results we got on version 3 and where we might start off. Right. So I've run an analysis. I've done quite an extensive analysis here. I've run with Cool and Pack and Warp, as well as the fill. So if I have a look, and the two, I'll run through a couple of the criteria quickly, just jump through them. So plastic flow doesn't have much, but confidence of fill. So the main two fields that I'm going to look at just for this example is going to be my fill time and my confidence of fill. Now the confidence of fill is how viable a mold is likely to be, or at least the filling, the plastic fill within our mold will be. So we can see in this particular, in our version 3, we've got a 77% of our mold is at a high sort of confidence, whereas 22.9% is in the medium sort of area. Now that's probably a bit high to even be considering, but like I say, a bit of a toy example, if you will. Nonetheless, let's have a quick look at a couple of the other sort of fields we have. We have a pressure drop field, and this is just from the default fill, flow form. And then I guess if we started looking into the cool, we can see our cooling circuit pressure and how it drops off towards the end of the circuit. But just notice the cooling, I suppose, side, because I will aim to repeat that. and we're running it in the Y. Right, and then we've got some deflection on the warp inside that we can see some results on our deflection, so 1.9 in the deflection. Now, I'm not going to go through all of those. Like I say, the main goal for today's little exercise is going to be to reduce a little bit of the fill time and mainly get a much higher confidence of fill. Right, so let's go ahead and start from scratch. Now, I do have the results already saved because, of course, a simulation does take a bit of time and we don't have too much of that. So let me get started here. I'm going to start from scratch. So importing my model, I'm going to import the top cover version 5, so the modified one with the fillets, and bring it on in. So it'll load and it'll create a mesh model out of our Inventor IPT. Picked up that the part was made in millimeters and general sort of dimensions of the bounding box of the product. And if I say next, it brings in a model. I'm just going to leave the default options for the most part, as I do know that it's going to come in. I've tested multiple times, as you would imagine. So finishing, I can see that my mold, or at least my product, has come through into Moldflow. Right, so let's get started on setting this up. So I normally start with adding in an injection location. So quite simply, we can see that I've got a bunch of wizard tools, or tool wizards, whichever way you want to call it. Harry Potter's all over the place. Right, so I'm going to go and add my nozzle to the same location. And to ensure that it's in the same location, I'm just going to right click and say properties, and just ensure that my X and right button and my Z are on 0. Good. So my nozzle's in the same location as the first iteration of this, my version 3 test, because I kind of want to get a like for like sort of comparison here on what the impact of adding simple fillets to my model are. Now I'm going to change my mold type to a single cavity, and I'm going to go to my geometry tab and just set my parting plane at this stage to 0. So once again, just keeping very simple sort of testing criteria at this stage, and aligning it to my previous testing. Okay, so we've now got a, sorry, I'm using my Inventor tools for rotation there. I need to stop holding shift when I rotate. So I can then go ahead and plan my runner. I'm going to do that. And just from a runner, in the runner wizard, I can then check various things like my properties of my actual runner. And I'm leaving everything as default, as I know that's what I did in the version 3. We've got a start diameter of 10 going down to an end diameter of 8. Our runners are 7 millimeters and our gates are 6 at this stage, which I'm not too worried about. As I say, we're more worried about just a like for like comparison on what the fillets would do. I'm going to bring that our main runner down below so that it will generate as I wanted to, and hit OK to let that runner go ahead and generate. Now that's my runner all set up. I'm going to go to the cooling wizard now. It was set up to run along the y-axis. It did have 4 passes, so it should be just fine at this stage. And I'm going to go ahead and hit OK, and just making sure that although it's going right through the coolant, it's not conflicting, so that'll be just fine and imitates my setup on version 3. As you can see on my actual mold, my top cooling pipes are actually halfway out my mold, so I'll just go ahead and make that A plate a little bit bigger at 40. There we go. They fit inside now. That'll do just fine. So with that in mind, I can then go ahead and jump back to my tools. So the home tab. Now I'm going to run the analysis wizard, which should run through a few of these criteria. You can do them individually, but they're just tabs on the same menu really. So in my analysis wizard, we can see that we have all our analysis types available. Now, depending on how I've set up and what I've got available, what I've set up for this analysis will determine what is available. If I untick the fill, I have the fill and pack option, cool and warp. So those are the 3 I would have ticked for the first analysis, but because we're only going to aim at those 2 criteria of fill speed and confidence of fill, I just need the fill for this particular example. And if I then hit the next button, I get to the material tab. So I'm going to use the same material as before, which was the polyprop easy flow, but just a generic sort of Autodesk material at this stage. And then lastly, depending on whether it's last or not, or I could go to the accuracy tab, which I will do. But nonetheless, I'm leaving everything on automatic. So like I say, a very generic type setup just for a like-for-like comparison. So at this stage, not even a mold specialist. I've just gone and basically run through a very simple simulation to compare whether I should be filleting my model or not at this in this design. So next, accuracy. We've got a bunch of options towards accuracy. I'm going to leave it on standard as, of course, we don't want it running too long. And from there, I'm ready to hit analyze. So if I go and push analyze, it'll start running the analysis. So if we just give it a second, we'll see the analysis start, and we'll see some loading bars down in our information tab in the bottom left corner. Right, so analysis is now running. There we go, we can see it starting with the mesh. Now, what I really do like about the Moldflow products is the ability to continue working while it runs a local simulation. So whilst there, let's go back and review where we were with the top cover. So, the top cover version 3 rather. So our fill time was at 1.094 seconds, and our confidence of fill was 77.1% in the high, 22.9% in the medium, and 0% in the low. Now, on my run that I've already completed, because we'll use that as the result, as this simulation will take just a little while. In our results, we have, and we can see it's a bit slow because I'm running an analysis in the background, but still usable. So jumping firstly to the full time, I've given a bit of a spoiler there, apologies, but nonetheless, our full time has reduced to 0.9792 seconds, and our confidence of fill is now up to 92.4%. Now, this is just from adding a 1 millimeter fillet on most of the edges, I'm going to say, not all of them. I think we've got 2 maybe on the top ones there. But nonetheless, just a couple of fillets have greatly enhanced the confidence of fill. And I guess these kinds of things are designer attributes. So we can use Moldflow analysis to get early insight on, I appreciate the irony of my usage of words there, but early insight on our mold designs. And hopefully this has been quite helpful to you. And if you are looking into getting into Moldflow Advisor, I recommend reaching out to us here at Man & Machine, and we'll definitely point you in the right direction. So thank you very much for your time today. That's all from me. Bye.